Welcome to Algebra 1 with Miss Betsy. Today we are going to be learning how to divide a monomial. The text that I'm using to drive this video today is the second edition of this book, Algebra 1 for Christian Schools, published by Bob Jones University Press. The sequencing is not the same with the third edition, so make sure that you're matching chapter topics and not section numbers. And it doesn't matter if you have a BJU Press book or not. You can use any algebra book, and this will give you a good instruction on dividing by a monomial. So let's go ahead and pray, see what our lame joke is, and get started with this. God, I thank you that you love us, that though you are the creator of the universe and Lord of all, you know us personally and that you walk in relationship with us. I ask that you would help us to study and learn the things that are placed before us today. In Jesus' name, amen. So, have you noticed there's a pattern to this, guys? I preface it by saying, here's a really bad one. Well, here's another really bad one. What do you call a fairy that doesn't take a bath? You call a fairy that does not take a bath a stinker bell. So, we are in section 8.8, page 350, if you have the same text that I do, and we are dividing by a monomial. And I think that you'll find this maybe a little bit more straightforward even in section 8.7, when we were talking about the two special products, the square of a binomial and obtaining the difference of two squares. And the reason that you're going to find this a little bit easier is because you already know all of the principles, the foundational principles that you need to be able to divide monomials. First thing that you need to remember is your division rules for signed numbers. Obviously, if you have a positive number divided by a positive number, you've known since whenever it was you learned how to divide, that your answer was positive. So 12 divided by 4 is a positive 3. Then we learned, beginning in pre-algebra, or even before that perhaps, that if we took two negative numbers and divided them, that gave us a positive number in our quotient as well. So we learned that as long as the signs are the same, whether positive or negative, the difference of the quotient of these numbers, remember that quotient is the answer to a division problem, the quotient is always going to be positive. But then we also saw that if the signs were opposite, if you have a negative 12 divided by a positive 4, or you have a 12 divided by a negative 4, you saw that quotient was always going to be negative. So when you're dividing, if the signs are the same, your quotient is positive. If you have opposite signs, as you do on this side of the board here, your quotient is always going to be negative. And if you don't have that piece of information totally solid in your mind, make sure you get it solid now, because you will have problems with getting the correct sign if you don't remember that quotient rule. And then another thing that you need to remember in order to be able to divide monomials is your quotient rules for exponents. In other words, how do you divide exponentials? What is x to the 5th divided by x cubed? Well, if you go back to your division rules for exponents, you saw that what you do is you keep the base and you subtract the exponents. So as we have here, x to the 5th divided by x cubed, x to the 5 minus 3, or x squared. Now, let me show you what is an exceedingly common error that beginning students make, beginning algebra students make, regardless of what age they are. What's wrong with this? And why is this a common error? X to the 6th divided by x cubed. Note, it does not equal x squared. How in the world did they end up with x squared? They looked at those exponents and they said that 6 divided by 3 is 2. Yes, it's true that 6 divided by 3 is 2, but we're not dividing numbers, we're dividing exponential expressions. What does x to the 6th actually mean? It means use x as a factor 6 times. X times x times x times x times x. Do I have 6? 1, 2, 3, 4, 5, 6. Divided by x used as a factor 3 times. When we cancel common factors, same factor in the numerator, pairs in the numerator and denominator. We have 1 pair, 2 pair, 3 pairs of factors in common that we cancel. What do we have remaining in our numerator? We have x used as a factor 3 times. This is a common mistake. Make sure that you understand, have totally solidified in your mind how you deal with dividing exponents. So the pattern would be, if you have, as long as the bases are the same, you keep the base and you subtract the exponents. This is the algebraic rule that we have that allows us, that tells us what to do, tells us how to handle x to the 6th divided by x cubed. And then we have one final thing that you would say, well, why do you even have to remember to tell me that? Well, sometimes things just slip our mind. And is that we can rewrite a division problem as a fraction. And that's going to be very, very important. And the reason we want to be able to take a division problem, write it as a fraction, is because then we can use our canceling common factors, and we can use our exponent rules, and it will be very neat and clear and concise what we're doing. So let's go ahead and look now on page 350. Okay, I'm checking, make sure that machine is recording, because the last time I didn't turn it on, but it's on now. Example 1 says, simplify 32 x, y, z divided by 4x. Now what did I say last that you have to remember when you are doing division problems? You need to remember that you can write a division problem in fractional form. And this is why we remind you of that, because you see a problem that says simplify 32xyz divided by 4x, and you might not immediately think of that as being a fraction because it doesn't look like a fraction. Remember, we said that rational expressions can be written in the form a over b, which is a fractional form, as long as your denominator is not equal to 0. So let's go ahead and rewrite this in fractional form. So our numerator becomes 32x times y times z divided by 4 times x. So what are we going to do next? We're going to take this 2 different ways. We can rewrite this where we have factored our numerator and our denominator into products of primes, or we can simply cancel common factors. If we prime factor 32, it becomes 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. It becomes 2 to the 5th times x times y times z, and 4, of course, becomes 2 squared. So we have 2 squared x, which is exactly what your text has done. Now they're going to use, over here, they're going to use our exponent rules that says that we have a base of 2, so we simply subtract our exponents. And I think it looks a little bit messy to do it this way, but if we have 2 to the 5th divided by 2 cubed, we subtract 5 minus 2 is 3. So that becomes 1. And we have 2 cubed in the numerator. X divided by x is 1. So you have 2 cubed times y times z over 1. Can we leave it in that form? No, we're going to go ahead and write out 2 cubed as 8. So we have 8 yz is the quotient that results when we divide these two monomials. Another way to do it is to be familiar enough with your factors that you can say, oh, 32 divided by 4. 4 goes into 32 8 times. I have a common factor of 4 that I'm canceling out. X and x are common factors. What do I have left in the numerator? I have an 8 times a y times a z. The denominator of 1 I don't need to show. So this was how we simplified 32xyz divided by 4x. So let's go ahead and look at this next one. Negative a squared b 9a. Negative 18a squared b divided by 9a. This is example 2. Now let me make sure I copied it, and you make sure you do the same as well. A squared b divided by a, because like I've said repeatedly, take the extra couple of seconds. That's all it takes. Take the extra couple of seconds to make sure you've copied your problem correctly. Now, let's just look at this. We have coefficients that we're dividing, and we have variables that we're dividing. We have a negative 18 divided by a positive 9. What are our rules, our sign rules, when we divide oppositely signed numbers? If you have a negative and a positive that are being divided, the answer is always negative. 9 goes into 18 twice. We're going to keep that negative sign. A squared, and did I count that wrong? A squared and a squared divided by a, you have a factor of a left, then you have a b. What do we have remaining in our numerator? Negative 2ab. These problems can get pretty messy and difficult to illustrate because you're canceling and renaming so many things. Let's just look at this again without doing any of those slash marks. 9a. And let's just write what we have. What is negative 18 divided by 9? Negative divided by positive is negative. 18 divided by 9 is 2. So we have a negative 2. Now we have a squared divided by a. There's no exponent there, but when that exponent is not written, remember it's understood to be 1. A to the 2 minus 1. Or we have a all by itself. B has nothing to cancel. So our quotient, which again is the same, is a negative 2ab. So this is all that you're going to be doing with these simple types of division by a monomial. But let's look at something that it is a little bit different now. And we'll go ahead and use example 4 to illustrate the principle 1527 divided by 3. We're simply going to use division of whole numbers. 15 plus 27 divided by 3. Now, what can we use here? I know a lot of you are thinking, well, Miss Betsy, obviously that's 42 divided by 3, so 14 is the answer to this problem. And that's correct, but let's look at this a different way. Let's separate these addends. Remember, addends are what you put together. They're the things that you add that gives you the answer to an addition problem, which is called a sum. So we already know the answer is 14. I'll put that up there. We're going to separate these addends. 15 divided by 3 plus 27 divided by 3. 15 divided by 3 is 5, plus 27 divided by 3 is 9. And look at that. We have 14 just the same way that we arrived at 14 here. And you might look at this and think, why in the world would I want to do it this way? You don't when you simply have whole numbers. We would find the sum in the numerator, which was 42, divided by 3. Then we would end up with our quotient of 14. But you're allowed to break this apart because of your fraction rule. Let me show it to you. Let me just do it this way. 2/5 plus 6/5. How do you add fractions together that have the same denominator? You add the numerators and you keep the denominator. So you have 8 over 5. What we did with this problem was we worked the addition of fractions with a common denominator in opposite order. Okay? Because what this gave us would have been 42 divided by 3. Okay? We can break these apart. And the fact that you can break this rational expression into a combination of addends comes in very, very valuable when we are dividing monomials that include variables. So let's look at this example here, which is number 5 on page 352. Don't need that 14 anymore. We have simplify, this is what is exactly going to be written in your book, simplify the quantity 12x squared plus 20x, close quantity, divided by 4x. And you can look at that and think, oh my word, I don't have a clue what in the world to do. First thing to remember is that division can be expressed in the form of a rational expression, which is where you're using that fraction bar. So we now have the quantity 12x squared plus 20x, all of this over 4x. And did you hear it come out of my mouth? 12x squared plus 20x, and I didn't write the x. There's my x. Make sure that you take enough time as you're working on these problems that you're careful to pay attention, that you don't drop a variable or write an exponent incorrectly. Now, what do our parentheses tell us to do here? It says combine within those parentheses. But we have an x squared and an x. And you can only, algebraic expressions are only like terms. You can only add them or subtract them. If the variable is the same, we have an x. But the exponent has to be the same as well, and we have a squared and a first. So there's nothing that we can do. We cannot combine inside those parentheses. The example that we just used before, you could combine within the parentheses because 15 plus 27 equals 42. So you wouldn't typically break that straight numerical fraction apart. But when you get to this example here, you cannot combine 12x squared and 20x because they're not common, not like terms. So what you do is you break this apart. So you have 12x squared divided by 4x. You use the sign, plus 20x divided by 4x. And now you have the division of two monomials. 12 divided by 4 is 3. X squared divided by x is x. You have 3x plus 20 divided by 4 is 5. X divided by x is x to the 0, which is 1. So the quotient that results when you take 12x squared plus 20x and you divide it by the monomial 4x is this binomial 3x plus 5. And you saw that I was reviewing that vocabulary for you as we went along, and you need to have that vocabulary solidly in your head. How do you check this? You check this by, you check your solution by multiplying the quotient by the divisor. Quotient times divisor. Let's see if we got the right answer. We have 3x plus 5, 4x. 4x times 5 is plus 20x. 4x times 3x is 12x squared. And you see that we ended up with the correct answer because when we multiplied to do our check, we ended up with dividend with the correct dividend. See, even I stumble a little bit on the terms for division. The dividend is inside the house. The divisor is knocking on the door. And the quotient is on the roof. Quotient is the answer to your division problem. All right? Let's go ahead and do another one of these problems. One final one. This has a trinomial in the numerator. We have 8x cubed plus 16x squared minus 4x. All of this is divided by a negative 4x. What we always need to do when we're have an expression that looks like this is you always want to combine like terms before you do any manipulation. Do we have any like terms here in the numerator? We don't, because the exponents are all different. So we're going to write this as 3 separate monomial division problems. First we have 8x cubed divided by a negative 4x. We use the sign that comes next, plus 16x squared divided by a negative 4x, minus 4x divided by a negative 4x. And I want to take a second and see if they did it this way. Plus okay. Subtraction is the same as adding the opposite. This one makes sense to you. Keep it. You're going to get the right answer. I'm going to change it a little bit. We're going to say plus 16x squared plus a negative 4x divided by a negative 4x. And that may make it a little bit easier for you to understand if you remember that subtraction is the same as adding the opposite. Okay? Now we simply have 3 monomial division problems to do. 8x cubed divided by a negative 4x. Positive divided by negative is a negative. 8 divided by 4 is 2. X cubed divided by x is x squared. Plus 16 divided by a negative 4, positive divided by negative, is a negative. X squared divided by x is x. Plus, now here we have the signs the same. Negative 4 divided by a negative 4 is a positive 1. Negative divided by negative is positive. X divided by x is 1. Now, Our final answer, we don't want to have plus a negative in our final answer. So we rewrite this as negative x squared minus 4x plus 1. Negative x squared minus 4x plus 1. Now, if we want to check this problem, what are we going to do? We're going to take that trinomial and we're going to multiply it by the divisor here, by what we divided by. And let's see what results when we do that. We have negative 4x times the quantity negative 2x squared minus 4x plus 1. Negative 4x times the negative 2x squared gives us a positive 8x cubed. Okay? Negative 4x times a negative 4x gives us a positive 16x squared. Our last product, negative 4x times a positive 1 gives us a negative 4x. Did we solve our problem correctly? Our original dividend, 8x cubed, plus 16x squared minus 4x is what we got when we multiplied those two together. So our check that we took the time to do here verified that we did our division properly. So that's the end of section 8.8 where we are dividing monomials. And I'll be back with the next section shortly.